In this video, I will show you how to build a sophisticated pH meter using an Arduino Uno. This project goes beyond simple plug-and-play modules by employing a specialized quad op-amp configuration to handle the extremely sensitive signals produced by a pH probe. Together, we'll explore how to bridge the gap between chemistry and electronics to achieve professional-grade results. At the heart of this design is the TL074, which contains 4 independent operational amplifiers. Each one plays a precise role in conditioning and stabilizing the probe signal. Op-amp 1, UA, the high impedance guard. Role unit tune buffer, voltage follower. Function, pH probes have extremely high internal resistance. Drawing even a tiny current can distort the reading. This op-amp, with its JFET inputs, looks at the probe's voltage without loading it. It replicates the voltage at its output with a NART drive capability for the rest of the circuit. Op-amp 2, U1D, the reference generator. Role voltage reference buffer. Function, to make the signal compatible with the Arduino, we need a stable offset. This op-amp takes the voltage from the R4-R5 divider and stabilizes it, creating a virtual ground. This shifts the probe signal upwards so that even negative voltages, common in alkali solutions, are translated into positive values the Arduino can measure. Op-amp 3, U1B, the precision scaler. Role differential amplifier. Function, the stage performs the math in hardware. It compares the buffered probe signal from U1A against the reference voltage from U1D. It then amplifies the tiny difference between them, scaling small pH changes into a measurable swing from 0 volts to 3.3 volts for the Arduino's ADC. Op-amp 4, U1D, the ground stabilizer. Role active ground or isolation. This op-amp ties into the ground loop, ensuring that the return path for analog signals remains clean and isolated from digital noise generated by the Arduino and OLED display. Supporting components. ICL7660U3, a charge pump that generates a -5 volt rail. This is essential because pH probes naturally produce negative voltages in alkaline solutions, and the op-amps need this rail to process them correctly. I've included the potentiometer in the simulation just to mimic the probe's behavior, but for the final build, we calibrate the meter by simply updating the probe slope and probe int constants in the Arduino IDE. This makes our meter more stable and much easier to fine-tune. Arduino and OLED. The Arduino samples the refined analog voltage at pin A2. Using the I2C protocol, it sends the data to the SSD1306 OLED screen, which provides a crisp digital readout of the pH value. By using this quad op-amp approach, we ensure that our pH meter is not only accurate, but also resilient against electrical noise and signal degradation. The result is a reliable instrument that combines chemistry and electronics into a practical DIY solution. Let's dive into the assembly and bring this project to life.